translations. A couple things that you need to know about them. One, they're isometric, which we touched on yesterday, meaning the shape stays the same size. So it's exactly preserved exactly as it was when it started. It's also called a slide transformation, because basically what's going to happen is you're going to take a shape, like let's say we take a triangle, and the triangle is just going to be kind of slid to a new area, like that. So let me zoom in just a little bit here. Thank you. So if I started here, we're going to be told, how do we get to the new place where we're going to put the shape? Now, we're not going to flip it around. We're not going to reflect it over a line. We're not going to do anything like that. We're just going to take a shape. I have to use a bottle cap like this. And I'm going to slide it to a new location. That's it. That's all we're doing. So I can slide it anywhere that I want to. We use a vector to slide the shape. Now, this thing called a vector, have you ever dealt with a vector before? Even heard of a vector? Alright, so a vector is going to look like a ray. So if I take, just for example, point A, and I do this to A prime. This is a vector. It looks like a ray. But what it's going to have is a horizontal and a vertical component. So this vector is going to have a horizontal component to it and a vertical component to it. So we could say that's A and that's B. So have you ever done anything that kind of looks like that before? Think back to algebra. When you're looking between 2 points and you're able to draw the triangle, what was that for? Starts with an S. Rhymes with cantaloupe. Slope. So, that's the best I could do it. Now, the vector is written like this. A represents your horizontal movement. So that's going to tell me where I'm going, how I'm going to change my x coordinate. Or how am I going to move in the x value. B represents your vertical movement. So B will tell me up and down. If A is positive, if A is greater than 0, we're going to move right. If A is less than 0, we're going to move left. If B is greater than 0, we're going to go up. If B is less than 0, we're going to go down. So basically what this does is this vector is going to tell us where we're going to put the new shape. We're going to start with the shape, and I'm going to get a horizontal movement, vertical movement, and then we're going to put that on a coordinate plane and kind of go from there. So first off, does that make sense on, alright, what a translation is going to be? We're just going to slide something somewhere else. And in order to slide it somewhere else, we're going to have directions on where we're going. The vector is going to give us directions. So the vector gives us the directions on where to go, where we're going to put our image from this. And it's going to be in not parentheses or brackets or braces. It's going to be in basically absolute value sign, or not absolute value, but inequality signs, it looks like. But they're not. I'm sure there's a name for it. My brain doesn't work at 7:25 in the morning as well as it should. So, are we okay with these ideas to start with? Alright, so with this translation, now let's flip over and let's take a look at some examples in the graph. And we might want to put it, there we go. I'm going to put my first shape, I'm just going to have a line. And I'm going to put the line here. Alright, here's AB. A has the coordinates -7, -7, and B has the coordinates -4, -2. I'm going to use the vector 4, 6 to translate AB to A prime, B prime. Alright, now, what does the 4 represent? It's A, and is this going to be a right or a left? We're going to move, it's positive, so we're going to move in a positive direction. And since it's the x-coordinate, we're going to move to the right. So we're going to move right 4 spaces. And that's going to tell us, take every shape, or every space, and we're going to go 1, 2, 3, 4. And this one will go 1, 2, 3, 4. So that represents my A right there. Does that make sense for the A? Now, what does the 6 represent? Yeah, we're going to move up how many spaces? 6 spaces. So I'm going to take this one and go up 1, 2, 3, 4, 5, 6. And I know you can't see that one perfectly, but there's my new, there's B prime. Now, from here, I'm going to go up 1, 2, 3, 4, 5, 6. There's my new A prime. And there's my new line. And since it's kind of hard to see at this moment, I'll highlight that. Now, A was at -7, -7, and where did A prime end up? A prime is at -3, -1. Now, how did I get from -7 to -3? How do you get, on a number line, how do you get from -7 to -3? Add 4. How do you get from -7 to -1? Now, where else do these numbers appear? The 4 and the 6. In the vector, isn't it? Now, with B was at -4, -2. Now, my vector said, I'm going to go the other way here. It says my x is going to go up, or going to go right 4. So I'm going to add 4, and then I'm going to add 6. So where should B prime be? What's -4 times, or -4 plus +4? 0. -2 plus 6? 4. Now, what are the coordinates of B? 0, 4. Or B prime, rather. So B prime is at 0, 4. So a cool thing that you can do with the vector is that you can actually add or subtract the vector values to the coordinates, and you can get your answers from there. All right, A, put it at 2, 3. B, put that one at 5, 8. And C, put C at 7, 5. And then use, go ahead and you guys try this. Use the vector 2, -4. To translate the triangle ABC. I'll give you about another 30 seconds or so. Remember, don't try to overthink this stuff. Alright, how are my x's changing? Right 2. So I could take A, C, and B and move them all right 2. Just like that. And now how am my y changing? Up or down? Down. How many? 4. 1, 2, 3, 4. So there's A prime. 1, 2, 3, 4. There's B prime, and C is 1, 2, 3, 4. There's C prime. And then there's our new triangle. Does it, just by looking at this, does it look like it's exactly the same as the original triangle? Is it bigger or smaller? All we did is we slid it down a little bit. Now the vectors would look like this. We just ended up using our components. But the vectors would be actually from A to A prime. But we switched it up by components. And we just used the horizontal and vertical components. Now, if you were to just take the points, and since I had 2, -4, that means I just add 2 to the x's and I subtract 4 from the y's. So if I add 2 and I subtract 4, what should I get for A prime? What's 2 plus 2? 4. What's 3 minus 4? -1. Is that where we ended up here? Yep. We ended up at 4, -1. Then I do the same thing. Plus 2 minus 4. What's 2 plus 4? 7. And 7, 4. That should be for B prime. And that's 7 and that's 4. So that worked. And C, same thing. Plus 2 minus 4. 9 and 1 should be C prime. There's 9, 1. And the vectors, like I said, the vectors are like this. The vectors are the diagonals. But when we get the horizontal movements for it, that's what we're going to get. All right, any questions?